Hello guys, in this video we are going to discuss the solution of the problem linked list matrix. So let us look at the problem statement. The problem statement says given a matrix mat of n by n size, your task is constructing a 2D linked list representation of the given matrix. So for instance, if this is the matrix which is given to us, we need to construct a 2D matrix of linked list, and post construction the linked list matrix looks something like this, and we need to return head of the linked list. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So the general idea behind solving this problem is to iterate on the matrix and convert the element of the matrix into a node. So we need to convert the elements to a node, and then these node is something which we are going to store in a table. And once we store each of the nodes in the table, then we are going to manipulate the right and down pointer of each of the nodes. So let us understand this with the help of an example. So let us say this is the matrix which is given to us. So the first thing what we are going to do is we are going to create a table, and the dimension of this table is same as the dimension of this matrix. So let us say this is the table which we have created, and in this table we are going to keep the same elements. It is just that we are going to convert them into a node. So let us say we have converted each of the element of the matrix in a node, and we have kept it in our table. So after conversion, the element will look something like this, and while converting it into a node, we are going to manipulate its right and down pointer. So let us say, for instance, this is the node whose entry we have made in the table. So what is the position of this node in the table? Well, the position of this node is 1, 1. So for this, what we are going to do is we are going to manipulate the down and right pointer for this node. So what we are going to do is we are going to update this pointer, and we are going to update this pointer. And this is what we are going to do it for all the nodes. And in this way, we will be able to generate our linked list matrix. So that's the discussion of solution, folks. Now let us discuss the pseudocode of this problem. So let us say we want to construct linked matrix, and a matrix is given to us. So for this, what we are going to do is we are going to take a table, and the dimension of this table is same as the dimension of the matrix. So let us do that. So in this way, we have initialized our table. All the elements of the table are none at the moment, and we are also going to take a head of the linked list, and we are going to set it to none. And then we are going to iterate on the matrix. So let us do that. So for I in range of len of matrix, and similarly for j in range of len of matrix. And the first thing which we are going to do is we are going to form a new node. So new is equals to node, and this is just matrix of I comma j. So we have formed a new node, and then what we are going to do is we are going to manipulate the pointers. So let us recall from our discussion. So let us say we are at this position, and we want to update the down pointer for this node and right pointer for this node. So if this is I comma j, then this value is I minus 1 comma j, and this value is I comma j minus 1. So let us use this. So if I minus 1 is greater than or equals to 0, then in such case table of I minus 1 comma j. So here we are updating the down pointer. So down will now point to new, and similarly if j minus 1 is greater than or equals to 0, then in such case table of I comma j minus 1 dot right will be equals to new. And then let us update our head as well. So if not head, which simply means head is empty, then in such case the first node is our head of the linked list. So head is equals to new. And towards the end, all we have to do is we just have to return this head. Folks, over here I have missed one step, and that step is essentially this new needs to be stored in the table. So table of I comma j is equals to new. So that's the pseudocode, folks. Now let us see how we have implemented this in Python and C++. So first let us look at the Python implementation. So for that, head is equals to none, and then we have a table with us. Then we are iterating on the matrix, and we are converting an element to a node. Then we are storing that node in a table, and then we are manipulating its down and right pointer. And if this is the first node, then head is equals to new, and towards the end we are returning head. So that's the Python implementation, folks. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ solution. So the C++ implementation is also the same, folks. We have a head pointer which is equals to null, then a table, then we are iterating on the matrix. We are converting an element to a node, then that node we are inserting it in our table, and then we are updating its right and down pointer. If this is the first element, then head is equals to new, and towards the end we are returning head. So that's the C++ implementation. Now let us submit our solution. So our C++ solution also got accepted. So that is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.